In this video, we're going to be talking about combinations and composition functions. So let's start with some warm-up problems here. So in this warm-up, you are given two functions, and you're asked to state the domain of each combination. So you might remember that when we're talking about combinations, we're talking about, either adding, subtracting, or multiplying, or dividing functions. So we're basically taking more than two functions and we're combining them. So that's what we call a combination function. So in this one, we're adding f and g. So what I like to do is first take the functions. So if I have this one be f and this pink one be g, so I'm going to take f, which is 2x minus 3, and I'm going to add, right, because this here says add. So I'm adding this equation with the other one, which is x squared minus 1. And so if I'm adding these two, all I'm doing is combining like terms if I have any. So I have an x squared, but I don't have any other more x squared, so I just have ax squared that comes down. I have a 2x, but it's the only x that I have, so I have a plus 2 that comes down. But I do have a negative 3 and a negative 1, so those two can actually combine to give us, well, negative 3 minus 1 is negative 4. And so that is my final answer. Now, here's the thing. So I have simplified, but it also states the domain. So if you want the domain, that means that this here is, you're asking what x values work for this function. Now, keep in mind, this is a quadratic function, right? So this is a quadratic function. And how do I know that? Well, it's because this x, the highest power for this x is an x squared. So I'm going to be drawing a parabola. So in this case, parabolas domain is always all real numbers. So in that case, that is my actual domain. Let's try another one here. So this one's subtraction. So I'm going to take f. It says here f comes first. So that's going to be negative 2x minus 3. But this time I have a minus sign and then my g equation, which is x squared minus 1. Now with subtraction, make sure you distribute that negative sign that's in front of that parentheses. And that's why I always like to use parentheses when I'm building a combination function, because just in case I need to distribute that negative. So parentheses are always nice to have. They're sometimes they can be redundant, but they're always nice to have just in case. So let's go ahead and distribute, and we'll have 2x minus 3 that comes down since there's nothing in front, but this negative will get distributed, so that's negative x squared plus 1, and so we're going to combine like terms. Again, that x squared is by itself, so we're going to just bring that sucker down, and the 2x is also by itself, and it's a positive 2x, so let's bring it down. So the only two that we can actually combine is a negative 3 and the positive 1, so negative 3 plus 1 is negative 2. And so that there is my simplified answer, but remember, we still need to find the domain. And again, this is a quadratic equation. So if I have a quadratic equation, I'm going to get a parabola. And this one, if you guys can't tell, is a upside down parabola because this x squared has a negative sign. But that's not relevant because if it's a parabola, parabolas always have a domain of all real numbers. Oops, I meant to do that in black. And so there we go. All right, let's get into multiplication here. So this says f times g. So again, I like to use parentheses here. It really helps when it comes to knowing that I'm multiplying these two. So if I have two parentheses here and here, this might look like foiling because it is. So I'm going to FOIL this out. So take the first term, distribute to both of the other sides. So that's going to be 2x cubed minus 2x. And then I'm going to distribute the negative 3, so that's negative 3x squared plus 3. And so from there, combine the like terms. So notice how x cubed and x squared there by themselves. So I'm just going to bring them down. Actually, now that I look at them all of these can't combine. There's only one type of each. Like this is an x cubed, x to the first, x to the second, and a constant. So you can't combine. So this is your final answer. Now, some people are really picky and they like to make sure the powers are in order, but you don't have to. So I'm just going to keep it here. But you can put the powers in order from highest to greatest. Now, because I notice is a x cubed, and x cubed also is all real numbers, because if you remember, an x cubed looks like this. And notice that it's always pointing towards the left and the right with an arrow. So it's going to be going to negative infinity to positive infinity. So this means that it's all real numbers. So all real numbers for cube equations and all real numbers for quadratic equations. Okay, let's take a look at this next one here. So this next one is a f divided by g. So let's take our f here, 2x minus 3. And we're going to divide that by our g, which is x squared minus 1. Now, in this case here, I can't really simplify any further because there's nothing for me to cancel out. So in this case, whenever you have a division or a function that looks like a fraction, you might remember that this is what we call a rational function. So whenever you have rational functions, if you go back to, I think it's journal 1 or one of the earlier journals, you cannot divide by 0, meaning that the denominator can never be 0. So in this case, what we have to do is take our denominator. We're going to set the denominator equal to 0 because it's the number that you can't equal. So we're going to work this out to figure out what x makes this equation fail. So in this case, we're going to solve it like normal. We're going to add the 1 over. So that'll be a positive 1. To get rid of a square, you have to take the square root. So x equals, or x cannot equal, square root of 1 is 1, but you got to put a plus and minus. So in this case, x cannot equal positive 1 or negative 1. So for your domain here, so this was your actual equation. You can't simplify that one. But the domain basically is all real numbers except, so x cannot equal positive or negative 1. So I can either say that what numbers can work or what numbers don't work. So like this is saying like all the numbers work except for plus and minus 1. So there we go. All right, so now that we are done with our warm-up here, let's get into definitions. So combination functions, we've kind of run through it, but basically you can have two functions and you can add them like what we did. We add them and then we subtracted some if there's a subtraction sign, or multiplication or division. So those are all the operations that you might see with combination functions. And so we'll do a few here as a practice. So this one is saying we're going to take f and add it with g, but this 2 here is saying that, well, after you add your functions, you need to plug in 2 for your x. So that 2 represents the x. So let's go ahead and set this up like we normally would do. So we have our f function and our g. So our f here is 2x minus 3. And we're going to add it with g, which is x squared minus 1. And I think this is the same equation as we had up there. So I'm going to, let's double check here. I think this is the same equation. So f is 2x minus 3 and g is x squared. Yeah. So this is the same equation. So I'm going to skip a few steps and just go ahead and write the simplified answer since we already have it at the top. So this would end up giving us x squared plus 2x minus 4. And so what we're going to do now is we got to plug in 2 for our x. So it's like I've combined all their like terms. I'm going to plug in 2 for our equation. So this is going to be 2 squared plus 2 times 2 minus 4. And if I work this out, I get, 2 squared is 4 plus 4 minus 4. And so if I combined all my numbers here, or I add them up, I just get right here, 4. So 4 is my answer. This next one here is subtraction, but we've already subtracted the 2 equation up there. So all we're doing is taking 2x minus 3, and we're subtracting it with our g. And like I said, this is the exact same equation as before, so I'm just going to take what I had up here as my answer. So that's negative x squared, negative x squared plus 2x minus 2. And now I'm plugging in a 3 for my x here. So if I plug them in, let's see what we get. So remember, order of operation, you got to do exponents first before you can distribute that negative. So that's 3 squared, which is 9. Pull down that negative. 2 times 3 is 6, minus 2. So if you combine all these numbers, negative 9 plus 6 is positive 3. Minus 2 is going to give us, am I thinking this correctly? Negative 5, I think so. So we get negative 5 as our answer. All right, now we have multiplication, and again, this would just be taking our equations, f, and multiplying it with our g equation, which was x squared minus 1. So I'm going to go ahead and redo this one because I don't want to flip back and forth, so I can easily rework this out. This is 2x cubed minus 2x, and then if I multiply this 3 here, this would be negative 3x squared plus 3. I think that's what I got before, so let me double check. Yes, so now we're going to go ahead and plug in that 2, that negative 2 that was in our equation. So if I plug that in, let's see, negative 2 cubed minus 2 negative cube, negative 2 minus 3, negative 2 squared plus 3. So just working it out, make sure you do the exponents first. That's negative 2 cubed, so that's going to be negative 8 times 2. These two, if you multiply, you get a positive 4. This one here would be a negative 2 squared, so that's going to be positive 4 plus 3. Negative 8 times 2 is negative 16 plus 4. Negative 3 times 4 is negative 12 plus 3. So all you're going to do is combine all the terms together. So negative 16 plus 4 is negative 12 minus 12 plus 3. So if I add these two together, that's negative 24 plus 3. I believe that would be, I'll just write it out so I don't make mistakes, be negative 21 as my final answer. All right, and last but not least, I have this one here for division. So that equation was my 2x minus 3 over my g, which was x squared minus 1. And so in this case, I'm plugging in a 5 into this equation, so both x's get a 5. So if I work this out, that would be 2 times 5 minus 3 over 5 squared minus 1. So that's going to be 10 minus 3 for the top and 25 minus 1 if I work it out. And so this would give me 7 on the top. 10 minus 3 is 7. 25 minus 1 is 24. And so in that case, 7 over 24, I can't simplify it any further, so that is my final answer. Okay, so in the next video, I'm going to talk about composition functions, but hopefully this gives you a better idea on how to do combination functions. Bye, guys.